I just wanted to go over some of these log examples with you. So for this example here, we can see a single log on one side of the equation. In order to solve this, all you need to do is convert to exponential form. Here's the base right here. Here's the exponent over here. And then it equals to 3x minus 2. So we converted to exponential form by finding the base, 3, and the exponent, 2. So I have 3 squared equals 3x minus 2. So 9 equals 3x minus 2. Add 2 to both sides. 11 equals 3x divided by 3. 11 thirds equals x. When your unknown occurs in the exponent, this is when you have to use logs in order to solve the equation. There are 2 logs that are in your calculator because they're the most used. The first one is the common log. Here it's base 10. You can see that a base isn't written, so if there is no base, you assume the base is 10. The other one is a natural log. It's ln. This one is base e. So if you see those bases in your equation, you know to use one of these logs, just depending on what base is showing up. So let's do these examples here. Part A says e to the negative 2x equals 1/3. Here, you want to take the natural log of both sides of the equation. The natural log of e to the negative 2x equals the natural log of 1/3. The natural log of e to the negative 2x is negative 2x. You can think of it in a way as canceling. And then on this side, we still have the natural log of 1/3. Lastly, we'll divide both sides by negative 2. And this here would be the exact answer, the natural log of 1/3 divided by negative 2. I see nothing wrong with this answer. There's no need really to approximate it unless you specifically been asked to do so. In the next problem, I'm seeing a base 10 here, but in order to use the common log, I need to isolate the exponential first by dividing both sides by 8. Now that I have isolated the exponential term, I can use the common log, which is just log. So we're going to log both sides of the equation. Okay, so the log of 10 to the 2x minus 7 is just 2x minus 7. So you can think of log and a base of 10 as canceling. I have log of 5/8. Okay, and now I need to go ahead and solve for x. Log of 5/8 is the exact number. I don't want to get an approximation. I want to leave it alone because I do want to get the exact answer here. So I'll go ahead and add 7 to both sides. And lastly, divide by 2. And here we have the exact answer. Let's try an example that is an application question. The normal healing of wounds can be modeled by an exponential function. If A naught represents the original area of the wound, and if A equals the area of the wound, then the function A of n equals A naught times e to the negative 0.35 n power. Describes the area of the wound after n days following an injury. After how many days would the wound be half its original size? Okay, so we know that A naught is the original size. So we want to know how long it takes to become half of that, which would just be half A naught. So we'll go ahead and take our function and we'll set it equal to 1/2 A naught. And then we can solve for n, which will tell us the number of days it would take to become half of its original size. Okay, so I'm solving this equation for n. I'm going to first go ahead and divide both sides by A naught, and then it will go away. Okay, cancels out on both sides. So I have 1/2 equals e to the negative 0.35 n. The base here is e, so I will be using the natural log on both sides. The natural log of 1/2 equals the natural log of e to the negative 0.35 n. So the natural log of e to the negative 0.35 n is negative 0.35 n. So natural log of 1/2 equals negative 0.35 n. Now I can get the exact answer by dividing both sides by negative 0.35. But the answer is the number of days, so I think I will get an approximation. So I'll put this in my calculator. Natural log of 1/2 divided by negative 0.35. So it's about 2. So in about 2 days,